All right, I think we've got a good number of people here, so we'll get going. Hi, everybody. My name is Matt DeVerna. I'm a PhD student here at Indiana University. I'd like to welcome you all to the Observatory on Social Media's second Awesome Speakers event with Gianluca Stringhini, who I'm going to introduce in a bit more detail a little later. But before we get started, I'd just like to talk quickly about the Observatory for anybody who has not really been sort of properly introduced to our group. So the Observatory on Social Media, with the acronym OSoMe, which is pronounced awesome, is a joint project at the Luddy School of Informatics, Computing, and Engineering with the Media School at Indiana University. So we're meant to be a sort of interdisciplinary group. We're interested in really all things at the intersection of media and technology. And as the name suggests, we have a particular focus on social media. We're also really interested just generally in technology, information networks, and that kind of thing. We conduct rigorous academic research, build analytical tools and software for both scientists and journalists, and work to educate the next generation of computationally skilled media professionals. So if you're interested in learning more about the Observatory, I have a link to the website there at the bottom of the page, and you can visit that website to check out our latest research tools or really anything else. Now, as part of the sort of interdisciplinary mission of the Observatory, we've organized the Awesome Speakers virtual event. So the event's basically a bunch of talks that will be given by some of the brightest researchers and scholars who are working to rigorously understand how social media, the internet, and technology impact the world. We have a bunch of these talks lined up. If you're interested in learning more, I have the website link there at the bottom of the page. I can imagine that if you find this topic today interesting, you'll probably be interested in some of the future talks that we have lined up. Now, with that, it's really my pleasure to introduce Dr. Gianluca Stringhini, who is an associate professor in the Electrical and Computer Engineering Department at Boston University. He holds affiliate appointments in the Computer Science Department, the Faculty of Computing and Data Sciences, in the BU Center for Anti-Racist Research, and in the Center for Emerging Infectious Diseases Policy and Research. His work applies a data-driven approach to better understand malicious activity on the internet. And through the collection and analysis of large-scale data sets, he develops novel and robust mitigation techniques to make the internet a safer place. Today, he's going to be talking about computational methods, as the slide suggests, to measure and mitigate online disinformation. I'll now ask if everybody could give him a warm welcome with your digital Zoom hands. And Gianluca, I'm going to stop sharing so that you can sort of take the stage here.
All right. Can you see the slides?
Perfect. Yeah, it looks good.
All right. Thanks so much, Matt, for the introduction, and good morning, everybody, or good afternoon, depending on where you are. It's my great pleasure to be here. Today, I will give you an overview of the work that, together with my collaborators and students, I've been doing on developing automated techniques to better understand and mitigate online disinformation. And I use the term disinformation broadly here. I know that there are several definitions, depending on whether information is spread with a malicious intent or is shared in good faith, and so on. I come from the computer security area, so much of my work actually deals with malicious parties, but I'll try to make that distinction more explicit as I talk about the various sub-projects throughout this talk. Overall, if we think about disinformation studies and misinformation studies, it's very difficult to get a comprehensive view of what's going on online. Due to a number of reasons. And so most of the time we can really scratch the surface, so we can really just see the top of the iceberg. And there is so much more that we actually cannot study. So in my work, I actually try to go beyond this and try to get a more comprehensive view. And the reason why it's difficult to get a comprehensive view of what's going on is because there are so many services and there is so much content posted online that it's difficult to get an overview of all this content, and it's difficult to develop techniques that can automatically identify what is misleading, what is disinformation, and so on and so forth. Another reason is that disinformation is not only textual. So most of the work we see deals with text because we are very good at natural language processing and trying to identify textual content at scale, but there are also images and videos which introduce additional computational challenges. Finally, it's not really clear what works and what doesn't. So what do we do once we identify malicious accounts, for example? Especially these are not fake accounts, but they are real users sharing misleading content. Now we'll talk about the unintended consequences of the platforming, for example, towards the end of my talk. So this is what I want to cover today. So I will go through 4 main topics. So we'll start by looking at influence campaigns, which I understand was the topic of last week's talk. And I will show you what we did to basically identify more accounts that are likely to belong to these influence campaigns and help improving detection. Then I will talk about soft moderation of content. So I will show you that actually what was done by Twitter and other social platforms to add warning signs to online content, well, was limited. Didn't really cover all the content that should have been moderated. And then I'll present a technique that we developed to actually automatically identify more content that should be moderated. Then I'll talk about image-based misinformation, presenting some techniques that we developed to be able to trace images that are spreading false information and some measurement studies around that. And finally, I will talk about, as I said, the unintended consequences in the platforming communities, particularly. So what happens once we get rid of an online community and these people just move away out of the spotlight? What should we think about when that happens? So let me start with the first topic. This is work that was funded by an NSF grant. So we started looking at the problem of influence campaigns, where basically state actors control inauthentic accounts with the goal of shaping online discussion. So this is not only straight out disinformation, false information being spread online, but also it's really the shaping of controversial topics and trying to stir, a debate and try to polarize online discussion. So we did this study back in 2019, where we were looking at the Twitter dataset that was released by Twitter itself of accounts belonging to influence campaigns during particularly the 2016 US presidential election. And what we found by looking at what these accounts were talking about, so these were accounts belonging to Russian-sponsored campaigns and Iranian-sponsored campaigns. We did some NLP analysis here, where we were basically interested in understanding what kind of topics are these accounts talking about. And you can see the graphs on the top right. So these were based on word embeddings. So we took hashtags, and 2 hashtags are connected to each other if their vector embeddings are similar enough. So we can sort of identify topics, broad areas in which these accounts were active. And the one in the middle is the Russian accounts, and the one on the right is the Iranian accounts. And you can sort of see that they're interested in geopolitics as well as internal politics. The Russians in particular were targeting US issues, issues that were likely to stir debate. There were contentious. There is Black Lives Matter at the top, for example. The Iranians were interested in Middle East related topics. In general, we found that there were opposite in which candidates they were supporting. So the Russians were supporting then candidate Trump. The Iranians were supporting Hillary Clinton in their campaigns and so on. But so what is interesting here is that these accounts were really pushing contentious talking points. And this was sort of supported also by interviews and by news reports, for example, about the Internet Research Agency in Russia, where people would go to this building on the slide in St. Petersburg, and they were basically, clocking in, and during the day they would have to post about certain topics and stir debate. So we decided to study this further. And what we did, we looked at Reddit, because Reddit in the meantime released a dataset of Russian-sponsored troll accounts as well that were active between 2015 and 2018. And why is Reddit interesting? Because Reddit has this thread-like structure, so we could really see accounts talking to each other, replying to each other. And we could really see how these accounts were trying to stir up debate and cause controversy. So for example, this example on the left, you can see the four messages at the bottom. So there is one, the one with the account named Manlike, that was identified by Reddit as being a state-sponsored troll. The one in black that's anonymized was identified by our method, which I will describe in a second. And then there was an account that was deleted, so it was probably a troll account as well. And you can see how they start from a geopolitical issue, some controversy between Turkey and Russia and Obama and so on. And then you find an account that's actually supporting what's going on, an account that's actually going against it. And then a third account is actually accusing one of them of being racist. So what's going on here is that these accounts are all controlled by the same entity, and they're simulating a real debate, a real row, with the goal of getting actual real people involved in this and polarizing online discussion and possibly changing their opinion and so on. So based on these observations, we were wondering, what if we can learn the typical interaction patterns of these accounts, with the goal of identifying more accounts that likely belong to these influence campaigns. And identifying more accounts is actually key in better understanding and monitoring these influence campaigns. This is something that was raised in the talk by Joshua Tucker last week as well, that if we only rely on the accounts that are identified by social media platforms, we might actually just see part of the picture. So along these lines, we did a preliminary study where we were basically interested in understanding, are these accounts that are known trolls, so they belong to influence campaigns, interacting with each other more than just other accounts on those platforms? And do they respond to each other? And do they post messages with the same title and things like that? And we found that that was actually the case. And it's interesting to understand how Reddit works, because on Reddit, typically you post a news article or any web page to start your post. And so the fact that the title was the same just meant that they were reposting the same news article, because that's fetched automatically from the news page. So based on these observations, we developed a system called Troll Magnifier, which was presented at IEEE Security and Privacy last year. My student Hamas was lead on this project. And the idea here is that given a set of accounts that we know are trolls, we learn their typical behavior, and then we train a classifier based on that, and we go and find more accounts that are likely to be trolls as well, because they behave in the same way. And we trained a classifier based on random forest for this, and we were actually able to identify many additional accounts. So the results are in the paper, but our approach was able to reach 97.8% F1 score. And then we ran it on any account that ever interacted with a seed of 335 troll accounts. Remember, the idea is that these troll accounts talk to each other to simulate legitimate activity. And we found 1,200 more accounts that we believe belong to the same state-sponsored campaign. So suddenly we have a much bigger set that we can actually study to understand what's going on. And then we reached out to Reddit, try to get confirmation of this, and unfortunately they didn't get back to us. But we have a set of proxy indicators that help us understand whether these are likely malicious accounts or not. So we look at whether they've been suspended later on. We look at they were created on the same dates as other troll accounts, because these accounts are created in batches, and so on and so forth. So for 66% of them, we can confirm that some of these indicators are there. So we are fairly confident that they are indeed troll accounts. For the remaining ones, we find that they talk about the same topics as troll accounts, and note that our features are all metadata based, are all interaction based, so we don't really look at the topics. So this is additional confirmation that they are likely suspicious. And for example, they were talking about Black Lives Matter. They were trying to stir controversy against the police and so on in the US. Interestingly, we also found that they were promoting cryptocurrencies a lot. So that seems to be a popular topic there. And we also found that these accounts followed synchronized patterns. So the line in orange here are the accounts that did interact with trolls but were not detected by our approach. And as you can see, their activity is pretty much constant throughout our observation period. The accounts that were identified by Reddit that belong to our ground truth in green show spikes, and these were the times where they started new campaigns and they started being active to push certain topics. And our detected accounts follow similar patterns. Interestingly, the spikes do not overlap completely, so we were able to identify additional campaigns going on that were not necessarily part of a grant. Then we performed some additional case studies. So we wanted to understand, how did these accounts operate and so on. So remember, the idea is that these people, for example, in the IRA building would be given instructions on what to post on a certain day, and would also be given a script on how do you look legitimate. So if you were to pretend to be a regular US person, what would you do to appear legitimate? So we started to look not only at the contentious topics that we were posting, but also what else we were talking about. And we found that many of these accounts were posting on the same subreddits content that was seemingly legitimate. And here is an example. So these are 3 accounts. The one on the left was part of a ground truth. So it was identified by Reddit as being a troll account. The other 2 were identified by Troll Magnifier. And so you can see that these accounts were basically posting on the same subreddits, similar pictures, pet pictures, to appear legitimate. We also find accounts that were posting on joke subreddits and things like that. And that's interesting because that indicates additional potential mechanisms to identify malicious accounts. So if you were to look at a single account individually, maybe it will look completely benign to you. Obviously, it might have some controversial opinions. It might be posting in political subreddits, but it also has a bunch of activity that looks perfectly fine. And that's what people look like on social media. But if you put them all together, suddenly you see that not only their political topics align, but also the benign and completely harmless activity looks exactly the same. And that might be an indicator that actually there is some orchestration going on, and these accounts are not legitimate. Moving on, as I said, I want to talk about the soft moderation of misleading content. So this is work that was supported by an internal grant at Boston University. My student Pujan was leading this. So what is the idea here? So you may be familiar with soft moderation. We've seen it applied by social media platforms quite prominently. For example, during the 2020 US presidential election, Twitter started putting labels to tweets that were promoting, election interference, or the fact that voting machines were changing votes and things like that. So the goal here is to provide more context to users who could make an informed decision on, is this true, is this not true, and so on and so forth. Unfortunately, what we found by analyzing tweets in voter fraud datasets is that these labels were not applied uniformly. So you can see this tweet on the right. It's very similar to the one on the left. The topic is exactly the same, but no label was added to it. So what we wanted to understand is, can we actually develop an automated tool that can learn from content that was already moderated and find more content that should be moderated as well, that should receive these labels? And so what we did, we developed this system called Lambretta, which was presented at IEEE Security and Privacy this year. And Lambretta uses learning to rank techniques to identify candidates for moderation. So learning to rank is an information retrieval technique that is designed to be able to develop the optimal query that retrieves the optimal set of documents when you want to search for any content. Think about search engine type of use cases. But the way we use it, we want to find, given a tweet that was moderated, what's the optimal set of keywords that not only describes this tweet, but identifies more content that should be moderated. And so we apply this learning to rank technique to content moderation. And in particular, our system uses random forest with the Lambda Mart to build a model that will identify the set of keywords that are able to identify the best set of moderation candidates. And so after training, our system can actually identify an arbitrary, given an arbitrary seed tweet, can identify candidates for moderation. So we compare our system with previous information retrieval techniques or NLP techniques. And we find that our model, which is the red line, outperforms all of them. So on the x-axis, you have the F1 score for each claim. So for each tweet that should be moderated, how many candidates in our ground truth can we actually flag? And it's already much better than the second best performing approach, which was Yake. And it also outperforms more sophisticated techniques like BERT-based techniques, which intuitively should perform better because these techniques are more sophisticated, but actually that's not the case. And this is interesting because if we envision using these systems as an aid to human moderators, so they are given a set of candidates and then they need to make the final decision whether this should be flagged or not, well, our system is reducing the set of candidates that a human moderator would have to go through significantly, by over 5 times compared to the second best ranked model. And then we test our approach on a Twitter dataset related to the 2020 US presidential election. So this was containing misinformation, but also factual information. And so out of 4 million tweets, our approach identified 100,000 of them as potential candidates for moderation. And after inspecting a sample of these, we estimate about 3.9% of them are false positives. And these are mostly tweets that end up being refuting these claims, being satire and so on, which is sort of pointing towards a further work in this area, which I will touch back again later in this talk. And then we find that our false negative rate is 18%, which might sound high, but it's actually much lower than the second best performing approach, which is Yake, which reports 32% false negative rate. Probably the most interesting result of this study is that actually Twitter only flagged a small minority of tweets as misleading. So of these 100,000 tweets, only 4.31% of them received a moderation tag. So this is indicating that this tool could actually be very helpful in providing better soft moderation and a better coverage in the claims and in the tweets that should receive these warnings. Finally, we wanted to understand why did Twitter flag so few tweets? And in particular, we wanted to understand whether they prioritize their content moderation based on certain criteria. So we started looking at the popularity of the accounts posted content, the idea being that maybe they were moderating popular content from popular accounts more than just any content. And we found that that's not really the case, actually quite the opposite. The content that was moderated came from accounts that were less popular than the one that we flagged as being misleading, but was not moderated. And the same thing with the popularity of the tweets themselves. So we found that the content that was moderated received, less retweets and less likes than the one that was moderated. And make of this whatever you like. We don't provide an interpretation, but that's interesting. And definitely it's showing that soft moderation by Twitter could have been improved. Meanwhile, Twitter changed ownership and this all went away. Now there is no soft moderation anymore, but these techniques could still be applied to the same platform in the future or to other platforms as well. So Facebook and Instagram, for example, applied soft moderation in other cases as well. As I said, information and misinformation in particular is not only textual. So oftentimes we see images or videos that convey a false message, and actually being able to automatically identify them and analyze them is challenging because it requires many more resources than just text. So for example, we see manipulated images like the one on the top. It was from a Black Lives Matter protest, and the text on the sign was changed again to stir controversy. We see screenshots from newscasts. We see mislabeled or straight out false screenshots from videos, and so on and so forth. So the question is, given the amount of content that is posted on social media on a daily basis, how can we make sense and trace information that is misleading, visual information that is misleading? So we developed an analysis pipeline, which is based on perceptual hashing. Perceptual hashing is this technique that is able to tell if two images look similar. And the way it does it is by converting an image into a vector. Basically, it splits the image into quadrants, and each quadrant is identified by an identifier number. And then two images are similar if their hashes are similar. And since we can perform vector comparisons quite fast, that becomes a much easier problem than just looking at images. In addition to this, we store these hashes into a vector database, which is optimized to do this kind of vector comparisons. And then we identify images that have similar hashes, we group them together, and that helps us later on because we can basically either match images that are known to be misleading, that were fact-checked by fact-checking organizations, or we can go and look at these clusters and annotate them ourselves and tell, okay, is this misleading? Is this not? And so on and so forth. And just to give you an idea, that is very fast. So in our prototype, we are able to query an image out of a database of 200 million of them in 0.29 seconds. So we're able to really perform many lookups and scale this up and identify candidates quite quickly. And we applied this kind of techniques to many topics. So we applied them to COVID, which I'll talk about in a second. But we also had other work where we're looking at manipulated images or photography in general. We were also looking at the images shared by the state-sponsored troll accounts that I was talking about before. So we went beyond text in a follow-up paper. So let me talk about one of these examples. So this is a paper that will appear at CSCW next month. And this was led by my student Yuping. So what we did here, we were really trying to identify image-based COVID misinformation. But instead of following a top-down approach, where we are looking at content that was fact-checked, and we look for similar images, we decided to follow a bottom-up approach. So we looked at all tweets, or many tweets that were COVID-related. So we start from COVID hashtags, then we do a snowball sampling, we find more hashtags that were included in tweets together with them. And we get over 2 million tweets posted over a period of 3 months, and 339,000 of them included images. Then we perform perceptual hashing, so we find images that are either identical or similar. We group them together, and then we had 2 of my students actually develop a code book and annotated these images, whether they were misleading or not. And then we further analyze them. And just to give you a sense of the kind of things we found, we found that there were many types of misinformation. The details are in the paper, but you can, you probably saw some of this content yourself. We see conspiracy theories about the origin of the virus or the vaccine being, some sort of master plan to control people, and so on. We see false cures being advertised, like the use of vitamin C to cure COVID. And then again, we see other controversial cures, in this case, as a screencast of a news program. Then we wanted to look at what kind of misinformation do different types of users share. So we look for users who would self-identify as supporting either the Republican Party or the Democratic Party on Twitter. And we found that Republican users were often sharing these conspiracy theories that, COVID is a bioweapon, and so on and so forth, or that COVID was released to influence the election, and so on. We also find false and misleading information shared by Democratic users, but the type of information that we find here is quite different. So this would be either misleading information about the response of the Trump administration towards COVID. So, for example, this tweet saying that the Trump administration refused test kits from the WHO. That did not happen, actually. Or we find content that's actually satirical. So that's non-factual, but this is an example of a fake paper from the New England Journal of Medicine, where the authors are actually popular characters from medical drama, and it's talking about using disinfectants to treat COVID-19, making fun of one of the press conferences by President Trump. So this is not necessarily misinformation in the traditional sense, but it's actually pointing to the fact that maybe we need better techniques to identify content that's satirical or it's meant as a parody, and so on. Other things that we find that images flagged as misinformation did not get shared more than regular images. And that's interesting because that's sort of contradicting other work, including our own, that found that misleading content is shared more than non-misleading content. And the potential reason there is that our approach here was bottom-up. So we looked at content, we flagged it ourselves, while most previous work was looking at content that had been fact-checked. And maybe the fact that the content was fact-checked, and so it was fact-checked worthy, it was already popular, introduced some biases in those kinds of studies. So this is something that should be investigated further. However, we find that images that contain misinformation are more long-lived than regular images. So they are shared for longer periods of time. And as I said, we find all these images that are also satire and so on. They weren't the majority of our images by far, but the fact that they are there identifies, and the same issues we had with the Lambretta work, point to the fact that maybe automated techniques identifying that kind of content would be helpful here. Finally, the last topic I want to talk about, I'm diverging a little bit because this is not specifically only about disinformation, but it's also about online toxicity and online harassment and so on and so forth. But it is looking at what happens after a community is deplatformed. So we did this study looking at two communities that used to be on Reddit, and then Reddit suspended them. And as a reaction to that, those people created their own community and moved away on a standalone website. And so this was the case of the Donald, which was a community that became popular for spreading conspiracy theories. Some of our previous studies found that this community was one of the most effective, if not the most effective, in influencing other communities, in pushing conspiracy theories on other communities like Twitter or the rest of Reddit. And the other one is incels, so the involuntary celibates, which came under scrutiny because of violence and so on, and they were also suspended by Reddit. This was actually a few years before, in 2017. So we wanted to look at what happens, what differences can we identify in the community before it gets the platform on Reddit and after it gets the platform on the standalone community. So we performed a regression discontinuity analysis across several axes. So what we first find is that actually the number of users that does migrate is a minority of the users who are active on the original platform. And this kind of makes sense because Reddit is a general purpose platform where there are many subreddits about all sorts of topics. And so maybe somebody might be tangentially interested in whatever the Donald or incels are talking about, but they're also interested in other topics. If they're asked to move to a third-party community, well, maybe only the ones who are really committed to the cause or to the community will make the change. So the number of users decreases, but we also find that those that do move become more active. So the activity per user increases. So these are the really active users. Then we looked at toxicity, calculated using the Google Perspective API. And we find that the toxicity in the new community actually increases. Now, this might be because users get angry and become more toxic. It might be because there is no moderation in these new platforms, while Reddit imposes some sort of baseline moderation. And we also look at linguistic cues, and in particular, we find that there is a change in the use of words like we, they, and so on, which is sort of potentially indicating that there is some othering, they're identifying enemies and so on. So this sort of opens up a bunch of questions, I come from computer security, and in computer security, we've always thought that malicious content of whatever nature should be deleted. Malicious accounts should be suspended. And once that happens, the problem is solved. But actually, these are not bots. These are real users who are potentially migrating to other platforms, and they could even come back in other forms to the original platform. And we should think about these unintended consequences. So we have other work that I will not cover that looks at cross-platform harassment attacks. So people aggregating on these polarized communities and then going to a mainstream one, like YouTube, for example, and posting hate, attacking people, and so on. And the fact that they coordinate on a third-party platform makes it difficult for the target one to actually police the content, because they don't see their activity until the attack starts. So as a call to action, I think that going forward, disinformation research should consider a number of things. The effect of inauthentic accounts on online discussions. So I talked about these influence operations and accounts that look perfectly normal and are actually stirring debate and could potentially derail these conversations and polarize communities that otherwise would remain civil. The subtlety of online content when making moderation decisions. So we talked about content that maybe is refuting the misinformation, content that might be satirizing it. Automated tools have a very hard time distinguishing between them. And so that's something that we should think about. The effect of different modalities in the spread of mis and disinformation. So I showed you, how can we monitor images in a performant way. But these systems are not perfect. So there could be improvements there as well. And then finally, I talked about the unintended consequences of mitigation strategies. And with this, I thank you, and I'm open to questions.
Thank you, Gianluca, for a very interesting talk. You've covered a lot of material there. So I mentioned in the chat earlier, yes, please, everybody, show some appreciation. So we're going to start taking questions basically from the crowd. The way that we're going to try to do this essentially is, just raise your hand and you'll line up, and basically the order in which I see hands, I'll sort of take them off. So Phil, you're first. You can go ahead and unmute yourself.
Ciao, Gianluca. Thank you.
Ciao.
Great talk, as always. And thank you also to Matt and Caitlin for organizing. I appreciate that. So I have one quick clarification question and then one more general question. So in the last bit where you were talking about the migration, the changes that you were, I just missed this. The changes that you were observing was by the people who stayed on Reddit, or you were able to track those same people on the new platform, or it was just everybody on the new platform, whether they had
it was everybody on the new platform. So we looked at that, we compared the two platforms. We have another paper where we looked at the individual users, and in particular we looked at users migrating to Gab. So this was Twitter to Gab, and our findings are similar. So the people, after they migrated, their audience shrank, so their followers shrank, but they became more active and they became more toxic.
But when you say that there were few people that migrated,
these were just the active users on the two platforms, yes. Before and after.
See.
Yeah.
I see. Okay, thank you for that. That answers. Sorry. And then the more general question is, for some of this work, especially like what you showed at the beginning, the trolls detector and the Lambretta system, you are relying on supervised learning. So you're relying on some seeds or some labeled trolls or some labeled examples to train your model.
Yes.
Create the queries that or to train the classifier that lets you discover other previously unlabeled examples. But so how do you see that kind of approach working in the future as we move towards less moderation, less data available from platforms, Twitter completely stopping these information operations reports, and other platforms also decreasing their investments in moderation. How is this going to affect our research?
Yeah, so there's there can be, there are multiple answers, but there is no definite answer, I think. One, we can rely on third parties to flag content. So in much of our work, we are relying on fact-checking organizations, and then we go and identify content that should have been moderated. The problem here is that fact-checking organizations tend to react slowly, in quotes, compared to how quick information spreads online. So if you're trying to do that in real time or near real time, that's a problem. Another thing that can be done is identifying characteristics of this inauthentic activity that become generalizable. So if we can develop a tool that identifies suspicious activity, like these groups of accounts that are talking to each other in a certain way, and so on, then we would be able to generalize beyond the training set or the ground truth.
Thank you.
Mm-hmm.
Great. Is anybody else any other questions? Otherwise, I can ask a couple. Okay, Greg shared one in the chat here. It says, what are your thoughts on classifying accounts as almost certainly not promoting disinformation? That is, flip the problem on the head, find accounts that are almost certainly good, independent, trustworthy, and reliable. Do you think that's useful?
I think that will be an option, yes. Definitely.
So I could
I
frame it
wonder. Yeah, go ahead.
I was going to say, what the question makes me think of is another perspective that I've seen a little bit recently, which is that perhaps we should be trying to promote good content as opposed to stopping the spread of bad content. Is that something that is more promising, or is it challenging in other ways that you think?
It is challenging to identify what is good content. I think, but it would be an option. Yes. The problem is, would people trust whoever tells them that that's good content, right? So there would be other issues there. While if we are able to show that content is inauthentic, we are not really, especially in the troll magnifier case, we're not really saying, that's false, that's disinformation, that is not true, and so on. But what we are saying is that these are inauthentic accounts that are sort of colluding to polarize discussion in a certain way. And if these are inauthentic accounts, then you can make an argument that's probably more universally accepted to get rid of them and so on. Okay,
makes sense. Anybody else before I jump in here? Okay. So I'll ask the sort of staple question. Oh wait, Luca has his hand raised. Luca, you can go ahead and mute yourself.
Thank you, Matt. And thank you, Gianluca, for the insightful talk today. I was particularly interested in the results you got about soft moderation and this unexpected result about popularity. In a recent paper of ours, we found something similar and unexpected about the creation date, and accounts that were newly created were immediately removed from Twitter. And there was wondering if you found any other strange results or other features about content that was moderated beyond popularity.
I don't remember if we looked at account age. We might have. I think everything was pointing in the same direction. So accounts that were less established, for whatever definition of less established, were likely to be moderated more, at least in our results, which goes against the idea that everything was user-driven. So, the idea would be that people would flag content as misleading, and then moderators would go and check them. And so obviously popular accounts would get more flags, right? Or popular content would get more flags. And that was not reflected in our data at all, which was interesting.
Interesting. Thank you.
Sure.
Awesome. Yeah, I'll ask one sort of general question. You have here at the end sort of call to action in particular about different modalities. And I'm just curious what your sort of intuition is based on the work that you've done so far. Do you think that like perhaps text or image or videos or whatever maybe has sort of a either sort of more or less impact than one another, or is perhaps used differently by different kinds of actors in different places? I mean, it's such a big area that can be explored, but you've started a little bit, and I'm curious what your intuition is saying based on the work you've done.
I think in general, images are more immediate. So, we did work looking at image memes more in the online hate space than disinformation. And so they have the potential of going viral more because people will just share them without thinking, that's funny, whatever. They reshare it, and so on and so forth. So it's very important to understand this content as well, in addition to text. Oftentimes, you have, the text might not be misleading and the image might be, or vice versa. So it would be interesting to put them together, or maybe sometimes the combination of the two is what becomes misleading or hateful, and so on, right?
Yeah.
So think about a picture of a politician, which is not malicious in any case, in any sense, but then the caption is what contains the misinformation. If you don't make the connection, both look benign.
Right. Yeah, it's a really good point. Sort of framing the problem in different ways. So Armando has a quick question in the chat here as well. It says, is it possible to track the origin or the account igniter of an image used in a trend or astroturfing campaign? So I guess like try to find the person who's introduced the first image. Is something you guys look at all? It sounds.
Yeah, so we did work in that direction, and we looked at several online communities, and we could see images being shared across them because we could see the similarity. And then we could either trace the origin of the image, or we had this statistical technique called Hawkes processes, so we could see which communities were influential in spreading content on other communities.
Interesting.
And we could also find, we did that in the context of Russian trolls, for example, so we could find which images were they actually sharing, and which images did they manage to make go viral on Twitter and on other platforms as well. And something interesting we found there, we found some early QAnon-like content being shared by Russian trolls, but that was way before QAnon even started. So this idea that the Democratic Party would be feeding off children, these kind of things, we see them as early as 2016.
Interesting. Okay, we're getting close to the end here, but I do have one more question. So as new tools like ChatGPT and generative models are sort of taking over the world, I'm curious if you're thinking about sort of making use of these in any ways. I know you focus a lot on sort of supervised methods, and these this I think sort of opens up a new door to lots of different opportunities. Are you trying to explore with these methods at all? Are there any
I think they have the potential to improve over other NLP methods. So they could be used for detection to improve various types of detection, including the keyword information retrieval one that we did. On the other hand, they could also be used by malicious parties to amplify their content. Suddenly, instead of someone having to type content and controlling 10 different accounts that talk to each other and so on, that could be automated to some extent. As long as it looks somewhat legitimate to a regular user, that could be effective.
Yeah, it's interesting. It seems like there's sort of, you're just going to have the models sort of fighting with each other to create the content or find it. Yeah, it's really interesting, and I think things are going to get more and more complicated. Phil, I guess one more question before we go.
If we have time for one more.
Yes, one more is good.
So Gianluca, you showed those results about the accounts that were moderated by Twitter as not necessarily being the most popular ones or the most popular tweets, and you said, I'm not going to comment about that. So I know we're being recorded, but curious if you have any thoughts on that. And I will mention that actually Matt has been doing research where we found similar things, not looking at moderation, but looking at accounts that had a very big, let's say, influence in spreading content from low credibility sources. Matt, feel free to add if you want, but basically the result was the same. Like accounts that were less influential seemed to be moderated more than accounts that were more influential, even though they were doing the same behavior.
Yeah, it's good to see that other people found the same thing. So it wasn't just our data set. I think obviously moderating popular accounts can cause backlash, and online platforms can be careful about that. But at the same time, I'm not sure what the effectiveness of moderating unpopular content would be, right? Only few people will see that content. So, obviously in our approach, we show that we can automate this, identifying candidates and flagging and so on. But if there is no willingness by the platform to actually apply the labels, then there's no point.
Yeah. Thank you again.
All right. Thank you so much.
I'm going to share a quick screen to plug for next week. So next week we have Dr. Francisco Rosner from the University of Washington, who is not talking about computational methods to measure, mitigate online disinformation. Obviously, we just covered that, but please check back in next week, and we'll hear from Dr. Rosner. And with that, I will call it a day and say thank you again, Gianluca. Yes, everybody.
All right. Thank you. Thanks for having me.
Yep. Have a good day.
Thanks, everyone.
Bye.
Thank you. Bye.